to reiterate about yesterday's lesson is that we're not trying to solve these equations in the way that we have been for the last month or so, solving stuff. What we're doing is trying to find the domain that won't break the function. So 2 days ago, when we first talked about domain and range, I gave you pictures. I gave you something like this, and I said, write the domain in interval notation. Right? And it's easy from a picture. It's easy to see that only the x's from here to here are defined for this graph, or this function. And it's easy to see that nothing over here is defined for that function. Like 0 doesn't have a point on there. X equals -2 does not have a point on there. It's only from 2 to infinity that has a point on that graph, and that's its domain, right? For a picture, that's easy. For functions that are just equations only, it's a little bit harder, and you have to use your conceptual understanding of the equation to figure out which x's you're going to exclude. On a picture, it's easy. Again, all of these x's are excluded, right? We need to use math on the equations to figure out what gets excluded. And the way we figure that out is we look at them individually and figure out, where would this function break down? Where would it be undefined? And at those x values, we exclude them. And we really only talked about 2 specific situations that would exclude some x's. We talked about problems like number 2, where there's a denominator with a variable. And we talked about problems like number 1, where there's a square root. So again, what we're trying to do is not necessarily math on the entire equation. We're not trying to solve by undoing radicals. We're not trying to undo the math. We're just trying to figure out where the function breaks down. At number 2, when I have a fraction, where do fractions go wrong? Like, where do they break down when what happens in a fraction? 0 in the denominator, right? So what we have to do is look at this denominator and say, hey, what x values plugged in would make that equal to 0? Because we want to avoid those. So we want to avoid anything that makes the bottom equal to 0. I really don't care about the top right now, because I'm just trying to find the domain. So I just sort of look at the denominator for a moment all by itself. Okay? I didn't do anything with the x minus 4. I didn't get rid of it. I didn't rewrite. I didn't solve. I'm just conceptually, as an idea, I'm just talking about the denominator only right now and trying to figure out what would make it 0. And so when I set this up and set it equal to 0 and solve, that gives me the values that would break the denominator, right? Square root. What did I do wrong here? Plus or minus. Right? So x cannot equal a positive 7 or a minus 7, because if it did, it would make the denominator 0, and that would be bad. I don't even care what it does to the numerator. I'm just trying to find the numbers that break my function. And so incorporating that information into trying to write your interval notation, every other number on that number line works except this one and this one. So everything here works, everything there works, and everything there works. And so when we go to write those in interval notation, we're saying that's the domain. That's the domain that will work for my equation. And there's 3 different pieces, and we just write our interval under there. So we just kind of model it. For this first interval, it's -infinity to -7, union, -7 to 7, union, 7 to infinity. Okay. You could pick any of those numbers, and it would be okay for your equation. That would be the domain. Questions about that one? Okay. For number 1, there's no fraction, so we're no longer caring about the denominator. What's different about number 1 is it's a square root. What kind of numbers break a square root and you can't do it? Negative numbers break that function. And so they cannot be part of the domain because they wouldn't work. Now that's fine to say in words, like you get that. You're like, okay, can't have a negative under there. Has to be positive only. And then what I see students do is they start guessing and checking. They're like, okay, well, I got to figure out the domain. I'm going to put 6 in for A. 6 worked. I'm going to put 4 in for A. 4 worked. But you could sit there and guess and check all day long. It would take you forever to figure out all the numbers. So that's why we want to do math instead. And here's the concept for that. Whatever is underneath the radicand, that has to be positive. Mathematically, in symbols, that means this. It has to be greater than 0, right? And so once I do that, once I take that thing out, and I haven't got rid of the radical, I'm just talking about what's underneath as an idea. I'm saying it has to be greater than 0. And then I have this inequality that I can solve for A. But we had one other piece to it. You can, yes, take square roots of positive numbers. However, you can also take a square root of 0. So we have to include 0 as well. It can be equal. And then now you just solve. You add 2 to both sides. You divide by 5. And now you have this inequality. You didn't have to guess and check 1,000 numbers to narrow it down. Math did it for you. And on a number line that looks like this, and as interval notation, it would look like this. Bracket 2/5 to infinity. Any number you pick out of there and plug in, you would be able to take a square root. It would give you something positive. Any number outside that range would give you a negative under the square root, and it would break down, it would fail. So this was just determining domains, the inputs that would work. Had nothing else to do with the actual function. Any questions about yesterday's lesson or yesterday's homework? Anybody do the homework? Excellent, excellent. Thank you very much. Y'all are my favorite. Don't tell everybody else. Any questions about the homework? No? All right, so let's just do the lesson. We're ready for the lesson? Let's do the lesson. When is your quiz that's coming up? Thursday. We are switching gears a little bit today to some other stuff about functions, okay? We spent the first day of the unit defining what a function is, finding domain and range from pictures. Yesterday we were given functions. We found the domain just from the equation. Today we're going to be evaluating functions, which means to find the y value when you're given an x value, or to find the output when you're given an input. We're going to do this 2 different ways. One is with graphs and one is with algebra or just math. This is one of those ways. Your I will statement is, I will find the value of f of a plus 1 for the function f of x equals negative 2x squared plus 4x. Who feels like right now they could do that cold without me even re-explaining it? You feel like you remember it all right? Who feels like they remember it, but they need to see it one more time before they're good? Most of you? Does anybody feel like they've never seen that before, ever, and I'm just making up stuff? Good, because you have seen this before. So just dig it out of the recesses of your brain. The first thing I want to review is function notation. So recall that a function is a relation of x's and y's that are related to each other, where each input x is matched to only one output y. And function notation, that word in class always means the symbols that we use for something. Like interval notation are the symbols we use to represent intervals. Function notation is another way of writing or naming a function, so it's easier to tell certain kinds of information. Like, for example, if you have an equation like this. This is an equation. y equals 3x minus 7. Function notation of that equation looks like this. What changed? What did I change? Just the y. What does it have now instead? F of x. Those are interchangeable notations. Y equals f of x. The reason why we even have this option, the f of x, or it could be g of x or whatever, is it allows us to identify certain kinds of information. And when we do some real world problems next week, that'll be a little bit more clear. This is the name of a function. And it also usually represents your dependent information, because y is dependent on x. X is your independent information. X is independent. Or your input, right? X is your input, y is your output. Those are all different ways of saying the same stuff. And we have this function right here. This is a general form for function notation. F of x, the name of the function is f, the independent information is x. In order to evaluate that function, the word evaluate means to find the value. Okay. It means if you're going to find the value of whatever y is after you plug in something for x, well, where are you going to get that x information from? It's whatever gets put in the parentheses right here. Like this says, determine the value of f of negative 2. Here's how we're going to do that. This was general form, f of x equals blah, blah, blah. This is specific. This is specifically meaning x is now negative 2. So to find the value of f of negative 2, you literally just take negative 2 and plug it in over there everywhere you see an x. You're substituting. Whatever's in parentheses, you substitute for x. Right, so take a minute and do that math, following your order of operations. And I'm going to randomly call on someone to give me their answer. So have your answer prepared. I have a very sophisticated method, which involves me just putting my pencil on the seating track and finding somebody. Okay, I found someone. I have my first victim. If it was closer to Halloween, I'd give you an evil laugh. But then it seems like a punishment. It's not really a punishment. It's not you. Following your order of operations, you need to do exponents first, and then multiplying next, and then adding last. I'm ready to call on my victim. Nathan, what is your answer, please? Negative 16. Who got negative 16? Okay, did anybody, the most popular wrong answer today has been negative 8 or 8. Did anybody get that? Yeah? All right, so let's talk about that. Chances are very good that if you got the 8 or the negative 8, I think it's that you didn't do the exponent first, I think, has been, or something. I kind of now don't remember what the common mistake was, just the answer. Exponents, so following your order of operations, you do this first. Negative 2 squared is positive 4. Multiplications next means a negative 8 here plus a negative 8 there. And that is negative 16. All right. So when x is negative 2, what is y? Negative 16. That's exactly right, okay? When your input's negative 2, your output is negative 16. So let's talk about this next one, f of 2a. What's up with this? How is that different from what we just plugged in? What's weirder about it? It has a variable, but the process is exactly the same. Whatever is in parentheses is what you're plugging in for x. What's in the parentheses? 2a. That is now going in for x. follow your order of operations, do that. I will pick a random victim. Order of operations, you do your exponents first. So you begin right here. 2a squared means 2a times itself. 2a times 2a is 4a squared. So that's just the exponent part. And then you have to bring down the times -2 plus the 4 times 2a. Then you do those multiplications, right? So that's -8a squared here plus 8a there. And then you think, okay, can I do any more math? Can I combine like terms? And the answer here is no, because they're different. One's an a squared and one's not. So if you can't do anything, you don't do anything. You just leave it. And that's your answer. Okay. We have one more to do before we move on to the graphs. What am I plugging in for x? A plus 1, right? Whatever it is in the parentheses, don't overthink it. Just look at it and go put it for x. Order of operations, parentheses first, but there's nothing I can really do or simplify there. So the next thing is exponents, which is the a plus 1 squared. Please be careful here. That does not just mean a squared plus 1 squared. Okay? It does not mean a squared plus 1 squared. That's part of it, but it's not the whole thing. Because what does a plus 1 squared mean? Even before that, before you actually do the math, what's the idea that it means? FOIL, because it's times itself, right? Okay. So it really means -2 times a plus 1 times a plus 1. Okay. This is what it means before I've even done any math. And then, yes, that's a FOIL problem, or box, or double distribute, or however you do. So you do FOIL there, and then you'll distribute the -2, distribute that 4, take a minute to finish out from there. Well, I picked my victim.